Okay, so we're looking at y equals 3x minus 5. That means my slope, my rise over run, my rise is 3, my run is 1. My y-intercept is negative 5. So I'll go to my y-axis, negative 1, negative 2, 3, 4, 5. So that's negative 5. My slope is 3 over 1. So I go 1 to the right, 3 up. 1 to the right, 3 up. And then connect those dots. There's your line. All right, part B, 7b. So by now you should be used to the fact that this y-intercept 1 just gets plotted directly. Nothing to do. Your rise over run is negative 2 over 3. So here's your rise, here's your run. You could do negative 2 over positive 3. You could do positive 2 over negative 3. Both are going to give you the same thing. I'm going to use this example to show you that, all right? So if I start at my y-intercept, my slope is negative 2 over 3. What that would mean is I go 3 to the right and go 2 down. There's my point. Now, what if I used this one instead? It says 2 over negative 3. What does that mean? You go 3 left, then you go 2 up. So 1, 2, 3, left, 1, 2. There's your point. And then you connect those 3 points. Sorry, my old man hand slipped over there, but that's the actual point, okay? So notice if I go 3 right and I go 2 down, or if I go 3 left and 2 up, it's still the same line. I'll look at something a little bit easier. Y equals 0.5x. This one sometimes confuses people, so I just want to talk about it for a second. Looks like there's no y-intercept, and that confuses some people. So remember, the y-intercept is just 0. So what that means is you're going to start at 0. Now we've got decimal slope here. So what that means is, if you look at it, 0.5, that's the same thing as 5 over 10, which is the same as 1 over 2. So all of a sudden it's not that difficult anymore. What you do is you go 2 to the right and you go 1 up. There's your point. 2 to the right, 1 up. There's another point. 2 to the right, 1 up. There's another point. Those are all points on the same line. So when I connect them, all those points wind up on the same line. Now, if you didn't like that fraction bit, I'm going to use the same strategy for the next equation. So if you look at question D, it says y equals 2.6x minus 1.2. So I'm going to use the same strategy. Instead of 2.6, I know I can write 26 over 10. And instead of 1.2, I can write 12 over 10. And then I can reduce both of those. 26 divided by 2 is 13. 10 divided by 2 is 5. 12 divided by 2 is 6. 10 divided by 2 is 5. You're still going to have to do a little bit estimating for the 1.2. So that's minus 6.5. Notice it makes your slope a lot easier. It's very difficult to go 2.6 up and 1 over, but 13 and 5, no problem. So that would look like this. Here's my negative 1.2. My slope is 13 over 5. So I'm going to go 5 right, and I'm going to go 13 up. So I'll just double check that. So if you look at it, this is 13, this is 5. And when you connect those two dots, you get a line like this. Now, if you take 13.5 and put it into your calculator, you'll see that it's 2 point something. So this doesn't exactly go through the point we want. And that's part of the problem dealing with equations with these decimals. So a question like this, 7D, is actually the motivation for us to move on to different kinds of systems of equations. You'll see this come up as we go along. Okay? This sometimes creates anxiety for people because you're not sure they're going to get the exact spots. And remember, in a situation like this, do the best you can, because I'm just looking for the effort that you were trying to get 13, you were trying to get 5. Line's a little bit off, or what? I'm a little bit off. We'll be okay.